Okay, the binomial theorem is really quite awesome. Here's what it's used for. That last deal, what if we, if we had x minus y squared, or that's, in fact, I'm not even going to make it quite like that. Let's say we had x minus 3 squared. Okay, well that one was pretty easy because it's the first term squared, x squared, double the middle, so negative 3x doubled would be minus 6x, and then the last term squared. Okay, fine. But what if it was x minus 3 to the third? Okay, now we actually have to go x minus 3 times x minus 3 times x minus 3. Well, we just did these first two. You do them two at a time. We know that that from what we just got done doing was x squared minus 6x plus 9. Then you have to take that times x minus 3 again. So now you multiply it all in. X times x squared is x to the third. That's minus 6x squared plus 9x, and then you do the negative 3 on top of all of that. So negative 3 times that one was negative 3x squared. Negative 3 times negative 6 is positive 18x, and negative 3 times 9 is minus 27. So we end up with x to the third minus 18x squared plus 27x minus 27. Okay, so that's a lot of busy work. What if we have x minus 3 to the fifth? Well, that means this. You got to take the first two, put them together. Then you got to take that times the next one, put them together, which is up to there. Then you got to take that times another one, and then that answer times another one, and it gets very tedious in a hurry. Well, there is a famous mathematician called Blaise Pascal that came up with something called Pascal's triangle. Pascal's triangle helps us with this. So let me first show you how to get Pascal's triangle. You have to know how to build it, and then after you know how to build it, you have to know how to use it. Okay, Pascal's triangle starts out with a 1 on the top. And then we're going to add one every row that we go down, we're going to add an extra 1. So the next one is 1, 1. So we're splitting the top one. Okay, from that point forward, every number in between there, so 1 plus 1 is 2, you add those up and you put a 1 around it. Okay, so I'll put a 1 out here. See, those two, 1 plus 2 is 3, 2 plus 1 is 3 with an extra 1. And it starts making this big triangle. So if I put a 1 out there, 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4 with an extra 1. Okay, let's build this a little ways. 1, those two make 5, 4 and 6 make 10, 4 and 6 make 10, 4 and 1 make 5 with an extra 1. 1 and 5 make 6, 5 and 10 is 15, 10 and 10 is 20, 15, that one's 15, 1 and 5 is 6 with a 1. Okay, a couple more rows. 1 and 6 is 7, that's 21, 35, another 35, a 21, a 7, and a 1. Okay, I'm going to go one more. 1 and 7 is 8, 7 and 21 is 28, this is 56, 35 and 35 is 70, 56, 28, 8, and 1. Okay, this is called row 0. This is row 1. This is row 2. This is row 3. This is row 4. The second number, this is row 5, 6, 7, and 8. So the second value is what row it is considered. So we have to know how when we're referencing go to row 7, I mean go to this row right here. Okay, here's how we're going to use Pascal's triangle. It's PFL. Oops, that should be an F. That stands for Pascal first last. And let's take this x minus 3 to the third. Pascal's triangle helps us expand this. Expand means put it in its long form without having to multiply it out. Okay, the P column is this is the row number. Whatever the power is the row number. So I need to go to row 3. So I'm looking right here at row 3. So the P column gets the Pascal numbers. 1, 3, 3, 1. Okay, F gets the first term, which is just an X. So that gets an X, 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 X. So we just put the first term in the F column. The L gets the last term. In this case, it's -3. So it's -3, -3, -3, -3. Okay, you start with in the first column, you start with the highest power that there could be, which would be to the third. So whatever that power is going to be the biggest power on the entire polynomial. So this is a third degree. So we start with the 3 and go down. 3, 2, 1, 0. And then on the other one, you go the other way around. Now, since it's a negative, I'm going to put a bracket around it. So this one's going to be 0, 1, 2, 3. So the first one you count highest down, and then on the last one you count lowest up. Now remember, I got to remind you of something. Anything to the 0 power is 1. It's not 0. So like -7 to the 0 power is +1. A fraction, 2/3 to the 0 power is +1. Anything to the 0th power is +1. So I'm going to multiply this row now. I take Pascal times first times last and see what we have. So we have 1 times x third times 1, which is x to the third. This next one I have 3 times x squared times -3. So 3 times -3 is -9x squared. Okay, the next one. Here I have a -3 squared. That's 9 times another 3 is 27. So the numbers are 27 with an x. And on this one, that's the number 1, not the variable. It's actually the number 1. So here I have -3 times -3 times -3, which is -27 times 1 times 1, which is -27. This is this thing expanded. X minus 3 all to the third is x to the third minus 9x squared plus 27x minus 27. Now we should compare that and see what we have. Looks like I missed a negative up here. I'm more confident in Pascal than I am here. I probably missed a negative on this one because this second term is -9. It's not -18. Oh, well, I just can't add. -6 plus -3 is -9 anyway. Okay, so that's Pascal's triangle and how to use it. So let's take a look at some examples and see. Number 2, they want us to find the coefficient described. So they want us to find this one, v squared u to the third. Okay, let's get Pascal going. So here it is to the 5th power. So when I put down my p, I want row 5, which is this one right here. 1, 5, 10, 10, 5, 1. Okay, so Pascal's going to be 1, 5, 10, 10, 5, 1. The first term. Okay, here the first term is a v. So the first term is v, 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 v. Then the last term. The last term is -2u. So -2u, 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 and -2u. Okay, the first one goes from the highest power, which is a 5, down. So 5th, 4th, 3rd, 2nd, 2, 5, 4, 3, 2, 1, 0. If you did it right, it should come out exactly right. And then this one is the whole thing. So I'm going to bracket it. See, it's the -2u all to the 0, all that to the 1, all that to the 2, all that to the 3, all that to the 4, all that to the 5. Now, this particular problem doesn't want us to write out the whole thing. They just want to know the coefficient of this term, the v2u3 term. Well, can you see it's this one right here? This is going to turn out to have a v2 u3 in it. They just want to know the coefficient in front of that one. So this one is 10. Now that's a negative 2 times negative 2 times negative 2. Negative 2 times negative 2 is 4, times negative 2 is negative 8. So that's negative 8 times 10. So that's negative 80 u2v3. So that's the one they want. They want the coefficient of that term, which in this case then is negative 80. So this problem doesn't want us to do the whole thing out. They're just asking us for what's one of the pieces of that. Had you multiplied it all out, what was this one? Okay, so let's find the coefficient of just plain old b. Okay, well this is a 4, or that's a 6th. So I'm going to do Pascal for row 6, which is right here. 1, 6, 15, 20, 15, 6, 1. 1, 6, 15, 20, 15, 6, 1. The first is all b's. The first term in that is a b, so these all are just a b. And then the last is a negative 2, so these are all just negative 2. Okay, so this starts at highest power, 6, 5, 4, 3, 2, 1, 0. And then this is 0, 1. Capture the negative because that's going to matter. So see that even ones will be positive because negative 2 squared is positive 4, but the odd ones will be negative. Okay, they want the coefficient of just b. Okay, see this one is going to be 1 times b6. That's going to be 1b6. That's not the one they want. They don't want b6, they want just b. Maybe it's this one. Well, no, b to the 0 is 1. That's 1 times 64. That's actually 64. Negative 2 times negative 2. They want this one. This is going to be 6 times b. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So this one ends up being 6 times b times negative 32. So whatever 32 times 6 is, 192. So it's negative 192b. So the coefficient of that one is negative 192. Got the idea? Okay, number 4, the fourth Pascal. Row 4 is 1, 4, 6, 4, 1. The first term is a bunch of u's. And they just want u. And then the last term is a bunch of 4's. So this is u to the 4, 3, 2, 1, 0. They want this one because u to the first is going to be just plain old u. So 4, that's a u. So 4 times 4 is 16u, so that coefficient is 16. Here they want just u again, but it's to the 5th power, so Pascal. Row number 5 is 1, 5, 10, 10, 5, 1. The first term here, u's kind of look like a 4. I'm just going to call this an x first. I like having letters that don't look like numbers. And then the last term is 2. So this is a 5th power, 4, 3, 2, 1, 0. This is 0, 1, 2, 3, 4, 5. I need to back up on question number 4 because I didn't get that one right. So let's finish this one and we'll go back and see it. See, on number 4, I didn't actually put the powers coming down on that one. So here here's the x term or the u term. So 2 times 2 is 4, times 2 is 8, times 2 is 16. So this becomes 5 times x times 16, which is 80. So that piece right there is 80x, so the coefficient in front of that one is just 80. Now let's back up to number 4 and fix that one, because I didn't do this. That should have been to the 0, 1, 2, 3, 4. That's not 16. it's 4 times u times 4 to the third is 64. 4 times 4 is 16, times 4 is 64. So I need 4 times 64, 256 I think. Yeah, 256 u, so the answer is actually 256. Got a little bit lazy on that one. Okay. Now they want to know, find the term described. So now on this next one, they want the third term. So we have Pascal 5. Pascal 5 is 1, 5, 10, 1, 5, 10, 10, 5, 1. So when they say the third term, this is the first term, second term, third term. They want this one. Okay, so the first one is a u. What's with u going on all these? And then the second one is 2v. Okay, so the first one starts high-low, 5, 4, 3, 2, 1, 0. And then this one would be all of this to the 0, all of this to the 1, all of this to the second. So that's the one they want, so I'll just stop there. So 2 to the second is 4, so this is 4v squared times 10. So I have 10 times u to the third times 4v squared. So the whole thing for the third one is 10 times 4 is 40. So it's 40 u to the third v to the second. That's the third term in the sequence. Okay, here we have one going to the 7th power. Okay, 7. 1, 7, 25, so Pascal. 1, 7, 35. No, that's not the third one. 1, 7, 21, 35. 21, 35, 70, 35, 21, 7, 1. The first term is a bunch of b's. Now they want the third one, so I think I'll just skip down to the third one. So B, B, B. The last term. Now the last term here is negative a, so it's negative a, negative a, negative a. Okay, it would start out the highest power here. So 7, 6, 5, 4, 3, 2, 1, 0, and then 0, 1, 2. So see, that 2 right there means we've got 2 negatives. So that now ends up being a positive. So as far as numbers are concerned, we have 21, a positive a, and b to the 5. So it's a b5a squared. Okay, now we want the 6th term of this one, and it's the 7th power again. Okay, 7th power, 1, 7, 21, 35, 70, 35, 21, 7, 1. Okay, the 6th term, 1, 2, 3, 4, 5, 6. That's this one. Okay, the first term first is a 2v. And the last term is a 1. So this would have been to the 7th. It would have been a 2v to the 7th, 6th, 5th, 4th, 3rd. So this one is to the 2nd. And then that 1 would have been to the 0th, 1th, 2nd, 3rd, 4th, 5th. Okay, so we have 35 times 4. So let's see, 35 times 2 would be 70 times 2, so it's 140. And then there's a v squared times 1. And one more, 5th term of a power to the 4th. So we need the 4th level of Pascal. That one's 14641. 1, 4, 6, 4, 1. And they want the fifth term. First, second, third, fourth, fifth. So they want the very last one. Okay, so first would be a B all the way down. And then last will be a 3 all the way down. Okay, this will be B to the fourth, B to the third, B to the second, B to the first, B to the 0th. And this will be 3 to the 0, 3 to the 1, 3 to the 2, 3 to the 3, 3 to the 4th. So this is 1 times 3 to the 4th. And 3 to the 4th is just a regular old 81 with no variables on it. Okay, number 10 wants the whole thing, so they want it to be expanded completely. So fourth level of Pascal now. So now we'll just pay attention to all of them. 1, 4, 6, 4, 1. The first here is 2n. The last is m. Okay, highest power is 4. 4, 3, 2, 1, 0. And then the other way around. 0, 1, 2, 3, 4. And we have them all. Okay, 2 to the 4th. 2 times 2 is 4, times 2 is 8, times 2 is 16. So this is 1 times 16 n to the 4th times 1. So it's 1 times 16 n to the 4th times 1, which is 16 n to the 4th. That's the first term. Okay, this one, it'll be 4, 2 times 2 times 2 is 8. So that's going to be 4 times 8 n to the 3rd times m. So that one is 8 times 4, 32 n 3m. Okay, the next one, 6 times 4 is 24. So I have 6 times 4n squared times m squared. So it's 24 m n squared m squared. Okay, here I have 4 times 2 n times m to the 3rd. So that's 4 times 2 is 8 n m to the 3rd. And then the last one, this whole piece is now 1. So it's 1 times m to the 4th. 1 times m to the 4th is just m to the 4th. And now you should put all this together as like you multiplied it together. So we end up with 16n to the 4th plus 32n third m plus 24n squared m squared plus 8n m to the 3rd plus m to the 4th. And you notice how the first letter of the alphabet is what's in charge: 4th, 3rd, 2nd, 1st, 0th. All right, number 11 will be almost exactly the same, only we now need the 5th Pascal number. So Pascal 1, 5, 6, 1, 5, 10, 10, 5, 1. The first is 2b. And the last is 3. You know, I want to change this just to make a point. Let's change the problem. Let's say that was minus 3a to the 5th. So it's negative 3a, negative 3a, negative 3a, negative 3a, negative 3a, and negative 3a. If it's plus, they're just all positive. But if one of them is minus, it goes every other one. And you don't even have to remember that because the powers will do that. So 5th power, 4th power, 3rd power, 2nd power, 1st power, 0. And then 0, 1, 2, 3, 4, 5. Okay, so here we have 2 to the 5th, which is 32. So I really have 1 times 32b to the 5th times 1. So anything to the 0th is 1, even if it's negative. So that one became 32b to the 5th. That's the first term. Okay, the next one, 2 to the 4th is 16, so we have 5 times 16b to the 4th times negative 3a. So, whatever 16 times 8 is. No, it's more than that. 5 times 16 is 80 times 3. It's 240, but it's negative 3. So it's negative 240 B4A. Okay, the next one. 2 times 2 times 2 is 8, so that's 10 times 8 times 9. Negative 3 times negative 3 is 9. So we have 10 times 8b3 times 9a2. Well, 8 times 9 is 72 times 10, so that's positive 720 b3a2. Okay, the next one, that's 4, but 3 times 3 times 3 is 27. So we have 10 times 4b squared times negative 27a to the 3rd. Oh, let's see. How about 27 times 4 first? 27 times 2 would be, so that's 108 times 10. It's with an extra negative. So 108 times 10 is 1,080 negative 1,080 B2A3. Okay, the next one. Here we have 5 times 2b. 3 to the negative 4 negatives is positive. 3 to the 4th is 81, so it's 81a to the 4th. So I've got 10 times 81a to the 4th, so that's positive 810 b(a) to the 4th. And then lastly, that's a 1 times another 1 times negative 243a to the 5th. So of course that's negative 243a to the 5th. And now we just put it down all together. So our final answer here is 32b to the 5th minus 240b to the 4th a plus 720b to the 3rd a squared minus 1080b to the 2nd a to the 3rd plus 810ba to the 4th minus 243a to the 5th. And there is the whole thing. Now notice this one is not having the a's first. I mean, you could rewrite it and put this one first, second, third, fourth, and fifth, and sixth. But the b term up here was first anyway, so the b term in the answer ended up being first. Okay, that's Pascal's triangle. It's extremely useful.